Yeah, can you go in, can you help me in going in presentation mode? Yeah, thank you. So thank you, Dr. Krishnan, for introducing me, and I should thank a good friend Sandeep for inviting me. Thank you, Gautam, for your hospitality. So I'll be giving my presentation. So it's basically not a presentation, it's a kind of a tutorial. So I have to give 3-hour tutorial today. So I divided into 3. And the first part, so what I will do is basically it's a question of monsoon modeling. I will talk about what you mean by monsoon and why we should really model monsoon and why monsoon is important. And the basics of some of the things which Dr. Krishna was discussing also, I may repeat it, so if you don't mind, and to have the completeness of the presentation. And this doesn't work, or this one, isn't it? This one, isn't it? Oh, USB was that. Yeah, good. So this is the way I will be taking class. So for the part 1, I will be talking about the basics of monsoon and mean monsoon and its variability. Monsoon has a large variability. If there's no variability, there was no meaning of, there's no question of prediction. So predictions becomes important because monsoon varies. And part 2 will be on numerical weather prediction, which Dr. Krishna was talking. So I will not go in detail and what are different techniques used for monsoon modeling. And third part will be what is the present skill of our IMDs or Indian forecast we make in India. And what is the prospect for AL methods and what we should do to improve this forecast. So you can interrupt me and ask questions in between if you want. Okay, so the sun is our energy, source of energy. Without sun, we would not have weather and climate. And we receive some X amount of energy from sun, and the same X amount of energy is given out to the space by Earth system. So there is a balance between energy received and energy going out. So temperature is same. Temperature is fixed at 15 degrees Celsius. If you take out temperature of the whole globe and average it, you get about 15 degrees Celsius. And climate change is happening because the energy which is going out is reduced because of the greenhouse effect. And so we get more energy, their system absorbs more energy, so temperature goes up. That's the basic concept of climate change. So sun drives weather and climate. And so we have this so-called cycle, seasonal cycle, because of movement of movement of Earth around the sun, and Earth has an orientation of 23.5 degrees. So we have 4 different seasons. So if you take a place like Dubai, for example, this is the Dubai's temperature. Yeah, this is Dubai's temperature for different months. You can see that red is maximum and blue is the minimum temperature. You can see that it is a beautiful cycle. It simply goes with the sun. And so you have a maximum around July, August. Whereas if you take a station like Nagpur, this line is the temperature. You can see that temperature is peaking around May. Then suddenly drops in June, July because we have monsoon. Whereas Dubai don't have the influence of monsoon. So Dubai's annual cycle is different, and whereas India's annual cycle is different. These vertical bars are basically rainfall over Nagpur. You can see that because of the monsoon we have, temperature goes down. So here the definition of season is winter, spring, summer, autumn, that kind of thing. Whereas we talk always of in terms of monsoon. Winter, pre-monsoon, monsoon, post-monsoon. So because we are more close to our monsoon. Monsoon is our bread and butter. So we have our season also is classified accordingly. And we have 2 monsoons. India is lucky we have 2 monsoons. One is southwest monsoon, that is the rainfall during monsoon season. Southwest monsoon season, this is the rainfall during northeast monsoon season. This basically occurs between October to December. but it is confined only over the southern parts of the country, or over northwest India we don't get. So we are lucky we have 2 monsoons, okay. We are fortunate to have 2 monsoons, and if assume that we did not have a monsoon, we would have been some country like Somalia. People will be carrying AK-47 and roaming here and there. So we are fortunate, we have 2 monsoons, we have plenty of natural resources available with us. And so I will briefly talk why monsoon is, what is the basic theory or basic dynamics of monsoon. And as I said that seasonal cycle of temperature is controlled by the position of sun. So during winter, this is the temperature distribution. You have cold temperatures here, warm temperature in the ocean. So temperature gradient is from south to north, whereas in May, June, July, temperature gradient just reverses. You get maximum more temperatures over land and low temperatures here, so you have temperature gradient from north to south, just reverses, okay? And and if you really want to see the vertical profile of temperatures, this is the vertical profile of temperature, this is the atmosphere, the height of the atmosphere. So and we have a lowest 10 kilometer is called troposphere, and most of the weather occurs within the troposphere. So the troposphere is more important. And there is some influence of stratosphere on weather, but not over the mesosphere. The thermosphere doesn't have any role on weather and climate. Stratosphere plays an important role. Okay, so when temperature is high, you get low pressure because warm is low pressure. And so in December, January, February, the pressure is high here and low here because the temperature is low here, so pressure is high. And here, when temperature is high, pressure is low. So the pressure gradient here is from north to south here, and whereas in the monsoon season, pressure gradient is from south to north, just reverses. Okay. And accordingly, the wind direction also is changed. And during December, January, February, it is all northeasterly winds, whereas in the monsoon season, the southwest monsoon season is all southwesterly wind. So pressure gradient, wind flows from higher pressure to lower pressure. Like water flows from higher pressure to low pressure, wind also flows from northern. Only thing is, so here, because the pressure is high here and pressure is low here, the wind should flow from southern hemisphere to northern hemisphere. But once you and these winds are not oriented exactly south to north, mainly because it's an influence of the Earth's rotation, Coriolis force. In the southern hemisphere, it will deviate towards left, and in the northern hemisphere, it will deviate to the right.
So why is there a pressure gradient and why is it changing?
The pressure gradient is different because of the temperature. Temperatures are different.
And that's because it is exposed to sun.
Basically, it's driven by sun. Okay, so this is the beautiful flow of monsoon flow. So you get this at about 1.5 kilometer, 850 millibar we call. And you can see that the monsoon flow comes from southern hemisphere, crosses the equator and goes on, and then here it turns again towards Indian region. And we call this as a monsoon trough. And most of these low pressure systems form here and moves across this India. And so the maximum flow, maximum wind speed is something over here. And we also have strong flow here, and we have, it's called Somali jet, we call it, and it's near Somalia. And so what it does basically is it brings a lot of moisture from, because it's all ocean, so there's a lot of moisture and brings to the Indian region. So it's,
One question. So you said we have two different monsoons.
yes.
Roughly how much is
Yeah, so about 70 to 90% of rainfall in the country is contributed by southwest monsoon, 70 to 90. And 70 is basically for Tamil Nadu. Tamil Nadu get maximum, countries like Andhra Pradesh, for example. There, they get more rain in October to December. Tamil Nadu is almost 50. They get a lot of rain in October, November, December. But most of northern parts of the country, like UP, Bihar, and all, maximum rainfall comes from southwest monsoon, Maharashtra, for example. So that's a bread and butter.
So we are trying to predict both the monsoons.
Yeah, so challenges is there for both, but we don't give much importance when you talk in terms of research. 90% of research is done on southwest monsoon. We assume that is more important, But because northeast monsoon is confined only to southern parts of the country, like Tamil Nadu, Andhra Pradesh, Kerala, and so that is very small place. So we assume that it doesn't have a role. But nowadays the importance of October to December rainfall also is increasing. A lot of awareness is happening. Tamil Nadu, countries like, states like Tamil Nadu, Andhra Pradesh, Telangana, they are also worried about. But there the agriculture, most of the agriculture is done during this season. Okay, and this is at a higher level, it's about 12 kilometer level, mostly it is easterlies, whereas in the lower level you can see it's all westerly winds, but if you go up, it all becomes easterly current. Okay. Yeah, so when talks about monsoon season, the monsoon current, then there is a analogy with the land sea breeze. Sea breeze, you must have heard about it, sea breeze, the breeze coming from sea, and it is very cool current. And while the physical mechanism is almost same, you can see in the daytime land will be warmer and the sea will be cold. So there is a pressure gradient from sea to land. So there is a current coming from cold ocean to land, warmer land, and it goes up and it comes back. So this is a so-called sea breeze, land sea breeze cycle. The night it just gets reversed. So it is very prominent, especially in the eastern parts of eastern coast of India. For example, Chennai, they have a sea breeze effect. The importance of sea breeze is it modulates your temperatures. So now warmer daytime temperatures will not be so high because there will be a sea breeze, cold sea breeze, and night also it will not be so cold because there will be a warm air advection. So this is the concept of land sea breeze. Okay. And this is the same concept people try to do it for monsoon. But I told that monsoon is nothing but a pressure gradient difference between sea and sea and land. So air from sea is coming from southern hemisphere, comes up and towards north, and it gives a lot of rain. So they assume that the land sea breeze concept can be applied to the monsoon concept, monsoon circulation also. So the initial theories were all based on this. So this is a famous first theory came from 1686, as early as 1686 by a person called Halley. And he hypothesized the main cause of the annual cyclone monsoon circulation is basically the differential heating between land and sea and caused by seasonal march of the sun. So sun drives this temperature gradient. And Halley in 1735 proposed that is okay, but then you had to also take into account the Coriolis force, nothing but the rotation of the earth. So that will create the southwesterly winds of the monsoon. Then later, very late, recent years, a person called Webster has proposed that MoES processes, for example, moisture content, etc., the heating because of the clouds, cloud formation, cloud condensation, etc., will also be a third element in the monsoon circulation. But this is the basic theory which started a very long time back. Still people talk about land-sea contrast as a main driving force of monsoon. But many times this contrast theory may not really be applicable, and there could be a lot of deviations from this theory. And one reason is, so this is the theory which we people are talking about. In the equator, for example, there is a lot of heating, so the air can go up, down, then come back. Similarly, in the northern hemisphere, the southern hemisphere also it happens. So this we call as a Hadley circulation. One in northern hemisphere and one in southern hemisphere. It's called Hadley cell. And the same concept, the monsoon people, they started talking about air from equator goes up, goes towards north, then goes up. This is the monsoon rainfall, then returns back and comes down, then again goes back. So it's basically a big circulation. And this is the monsoon circulation, and they assume that is mainly because of the land-sea contrast. But if you really so I can give this, yeah, it works. So you can see how the different months, the Halley circulation is getting changed into monsoon circulation, you can see that. So in the winter months, there will be two circulation, one in northern hemisphere Halley circulation and southern hemisphere circulation. The monsoon season, it's also big, large monsoon circulation coming from southern hemisphere to northern hemisphere, goes up, comes down again into southern hemisphere. But the theory doesn't really work. If the temperature contrast is main important criteria, if a temperature is more over land, it should drive the more monsoon. The monsoon strength should be more. But if you really take the temperature over land and plot against monsoon rainfall, when temperature is more, we should expect more rainfall, but it is not so. This is just negative. So when more temperature doesn't really drive the monsoons, so it can explain how the monsoon is coming, monsoon circulation, basic monsoon circulation, but it cannot explain the variability of monsoon. For example, 1 year monsoon is more, and that cannot be explained by land sea temperature contrast. So there's a big objection by some people, some elements, some researchers saying that this land sea contrast cannot be used to explain the variability of monsoon. It's not a really good example. So what exactly then monsoon is? How we can explain monsoon variability is, there's a concept of the morning, a few minutes before, Krishna was talking about so-called ITC set, intertropical convergence zone. It is nothing but the air of the two airs coming down and converging, and air will be going up and giving a lot of precipitation. So this is the red shows the northern hemisphere ITC set, and the blue shows the winter southern hemisphere ITC set, where E minus P is positive. E is evaporation, P is the precipitation exceeds surface evaporation E, and so this is the area where this shaded area where the precipitation is more